Guys, myself and Chandra from the Department of Electronic and Communication Engineering, studying in Srinivas Ramanujan Institute of Technology. Today we are solving the problem in differential equations and vector calculus in B.Tech first year, second semester. That problem is solve x into y square and z square into p plus y y into z square minus x square into q is equals to z into x square minus y square. Introduction to the problem. We have been tasked with solving a complex mathematical equation, exponential variables and coefficients. This presentation will guide steps to the finding a solution. Defining the variables x, y, z and pq. X, Y, Z. These represents the three variables in the equation, which could be any mathematical values or quantities. Q. These represents the exponents or powers associated with the variables x and y in the equation. Relationships. The equation suggests there are specific relationship between these variables and exponents that needs to be solved for. Expanding the equation, multiplying the terms. We begin by multiplying the individual terms on each side of the equation to expand it fully. Left side of the expansion, on its left side we have x into y square minus z square into p and y into z square minus x square into q. Multiplying those would give us xy square into p minus xyz square into q plus yz square into q minus yz power q equals to q. Right side expansion. On the right side we have z into x square minus y square. Multiplying this out gives zx square minus zy square. Simplifying the equation. To simplify the given equation, we can expand the terms and identify any patterns or relationship between the variables. This allows us to combine the like terms and reduce the equation to its most basic form. First one, expand. Multiply out the terms to reveal of the expression. Second one, identify the look for any common factors or patterns in the equation. Third one, combine. Group like terms together and simplify the expression. By carefully working through these steps, we can simplify the complex equation into more manageable form, make it easier to solve for the unknown variables. Identifying the patterns in the equation. Symmetry. The equation exhibits a striking symmetry with each term following a consistent pattern of subtracting the square of one variable from the square of another. Relationship between variables. The variables x, y and z are all interconnected with each term, representing the difference between the squares of the two variables. Signs and operations. The signs and operations of the use of multiplication, subtraction and exponentiation suggests a complex mathematical relationship between the variables requiring a deeper understanding to solve. Solving for x, y and z. First one, isolate x. Rearrange the equation to solve for x in terms of y and z. Isolate y using the expression for x, solve for y in terms of z, solve for z. Substitute the expression for x, y and z into the original equation and solve for z. Now that we have the steps laid out, we can systematically solve for the individual variables x, y and z. This will involve algebraic manipulation to isolate each variable in turn using the given equation and the relationship between the variables. Solving for P and Q. First one, isolate P and Q. To solve for unknown variables P and Q, we need to isolate them on one side of the equation. Second one, rearrange the terms. Rearrange the equation to group the terms containing P and Q together while moving the other terms to the other side. Third one, solve for P and Q. Now the equation is in the form of AP plus BQ is equals to C. We can solve for P and Q using algebraic methods such as substitution or elimination. Checking the solution. Verify the equations carefully. Substitute the solved values for x, y, z, p and q back into the original equation. Ensure it holds true. Examine the patterns. Look for any recognizable patterns or relationship between the variables that could provide further insights. Double check maths. Recheck all the algebraic manipulations and calculations to confirm there are no errors in the step-by-step solution. Applications of the solved equation. The solved equation x into y square minus j square into p plus y into z square minus x square into q is equals to z into x square minus y square has numerous practical applications in the field like physics, engineering, and computer science. It can be used to model complex systems, optimize performance, and analyze data. The equation ability to capture relationship between variables makes it a powerful tool for problem solving and decision making. This is the solution for the given problem. Given equation is x into y square minus z square into p plus y square into z square minus x square into q is equals to z into x square minus y square. That is equation 1. The given equation is in the form of p plus q equals to r, where p is x into y square minus z square and q is y into z square minus x square and r is z into x square minus y square. The Lagrange substitutory equation are dx by p equals to dy by q is equals to dz by r. And that is d by x into y square minus z square is equals to d by y into z square minus x square is equals to d by dz by z into x square minus y square. That is equation 2. Use the Lagrange's multipliers x, y, z. We get each ratio in equation 2. X dx plus y dy plus z dz by x square into y square minus z square plus y square into z square minus x square plus z square into x square minus y square. That implies x dx plus y dy plus z dz by 0. That is x dx plus y dy plus z dz equals to 0. Integrating, we get integration of x dx plus integration of y dy plus integration of z dz is equals to 0. That is x square by 2 plus y square by 2 plus z square by 2 is equals to a by 2. That is x square plus y square plus z square is equals to a. Use Lagrange's multipliers 1 by x, 1 by y, 1 by z. We get each ratio in the equation 2. 1 by substitute in the place of substitute 1 by x, 1 by y, 1 by z in equation 2. 1 by x into dx plus 1 by y into dy plus 1 by z into dz by y square minus z square plus z square minus x square plus x square minus y square is equals to 1 by x dx plus 1 by y dy plus 1 by z dz by 0. That is 1 by x into dx plus 1 by y into dy plus 1 by z into dz equals to 0. Integrating, we get integration of 1 by x dx plus 1 integration of 1 by y into dy plus integration of 1 by z into dz equals to 0. Log x plus log y plus log z is equals to log b. Log of xyz is equals to log b. That is xyz equals to b. Hence the general solution of f of a comma b is equals to 0. That is f of x square plus y square plus z square comma xyz equals to 0, where f is a arbitrary. Conclusion and key takeaways. Powerful equation. The solved equation x into y square minus z square into p plus y into z square minus x square into q is equals to z into x square minus y square is a versatile mathematical tool with applications in various fields from physics to engineering. Deeper understanding. By analyzing the patterns and relationships within the equation, we have gained a deeper understanding of the underlying principles and the interconnected of the nature of the variables involved. Problem solving skills. The process of solving this equation has sharpened our problem solving skills, teaching us to approach complex mathematical problems with systematic and analytical mindset. Practical applications. The versatility of this equation means it can be applied to the wide range of real world scenarios from engineering design to specific research, make it a valuable tool for professionals in various fields. Thank you.